Priority scheduling algorithm. Priority scheduling algorithm. Each process is assigned a priority and the CPU scheduler selects the process in the ready queue with the highest priority to execute next. We have here one example of priority scheduling algorithm, which is the non-preemptive priority scheduling. In the non-preemptive priority scheduling, the processes are scheduled according to the priority number assigned to them. Once the process gets scheduled, it will run till the completion. Generally, the lower the priority number, the higher is the priority of the process. The people might get confused with the priority numbers, hence indicate they're clearly mentioned which one is the highest priority and which one is the lowest one. Priority scheduling algorithms. We have here one example of priority scheduling, which is the non-preemptive priority scheduling algorithm. We have the process, the CPU burst, and the priority. First, we're going to make the Gantt chart. So at time 0, these 4 processes arrive. We have our first process as the lower priority number, which is the P4. So in P4, it will finish at time 50. The second one is the P3 was a CPU burst of 5. We're going to add it on P4. So at P3, it will finish at time 20. And the third one is the P2, who has a CPU burst of 20. Again, add it on P3. So at P2, it will finish at time 40. And the fourth one is the P1 was a CPU burst of 10. Again, add it on P2, which is 40. So P1 will finish at time 50. To get the turnaround time, we're going to subtract the time finished minus the arrival time. Since we don't have the arrival time, we're going to put it 0. So P1 is equals to 50 minus 0 is equals to 50. P2 is equals to 40 minus 0 is equals to 40. P3 is equals to 20 minus 0 is equals to 20. P4 is equals to 15 minus 0 is equals to 15. To get the average turnaround time, we are going to add the answers on P1, P2, P3, and P4 and then divide it by 4. So we have 125 divided 4 is equals to 31.25. The next one is to get the weighted turnaround time. We are going to subtract the turnaround time minus the CPU burst. So we have P1 is equals to 50 minus 10 is equals to 40. P2, 40 minus 20 is equals to 20. P3 is equals to 20 minus 5 is equals to 15. P4 is equals to 15 minus 15 is equals to 0. To get the average waiting time, we're going to add P1, P2, P3, and P4 and then divide it by 4. So we have 75 divided 4 and the average waiting time is 18.75.